Hello YouTubers, and welcome to this next video in the series on how to solar power your home. Now in the last video we kind of finished off with looking at the potential future with grid tie systems, in particular using microinverters on solar panels, and how you can connect that system to your home and then onto the grid. And there's certainly some very interesting permutations with that. Now I have literally just finished installing my own system. It's the first system that I've fully done myself. I've not installed a solar system myself before. And my system is based around the Enphase M250 microinverters, an outback inverter with their load, AC coupling load center, and then the Envoy gateway and various other bits and pieces. And we're going to take a look at that so you can understand what's involved and what you need to be aware of. The outback system that I've chosen is not cheap. However, it does have a lot of functionality that I missed in previous systems that were installed in two of my previous houses in South Africa. Systems where you want to control whether you feed back onto the grid or not. I was having to use complicated timers and relays to disconnect. I was having to judge the time at which I would switch over from batteries back to the grid, or from the grid back and charge the batteries from the PV. And a lot of that intelligence has been really simplified in the outback system. However, I said it's not cheap. So you need to be aware of this, and that the outback has its own limitations. Some limitations that we're going to talk about that I've learned more about. So in this video, we're going to have an overview of my system and how it hangs together. And then in subsequent videos, but starting with this video, we're going to go into more detail. On this video, I'm going to show you the installation of those Enphase microinverters, what's involved, and then the setup and what you can expect to see once you've got it connected to the internet. And following that, we will have a follow-up video where we focus on the actual outback inverter itself. And although I'll be using the outback inverter as the example I talk about, there'll be lessons learned that you can take away and consider when you're looking for an inverter for your own home or your own system. We'll then also have a look at the electrical system in terms of the US split phase system and the things you need to be aware of there, where you earth, where you bond, being aware of safety. Can you go and connect a system like this up yourself safely, or do you perhaps need to consider calling in a professional? Let's have a look at an overview of the system that I've gone and installed. Right, so looking at an overview of the system that I've just installed and put together, we've got the main grid, and in this case I'm going to be referring to the US grid, but you can certainly relate to your grids from around the world. But here in the US we've got a split phase system, and that means you've got two HOTs or two live connections. They'll be called hot leg 1, hot leg 2. Between those two phases you get your 240 volts, and then you've got a neutral. So for the most part, most of your outlets in your home are going to be getting 120 volts, and that's when you take a connection between the leg 1 and neutral, or leg 2 and neutral. And ideally what you're supposed to do is try and balance your load across those phases. And for your high power devices like your washer, dryer, your range, or your cooker, you'd connect across leg 1, leg 2, your two lives, to get your 240 volts. Now that service comes in through your main service breaker box, and your main normal household loads are fed off that. Now here you can see I've noted normal loads, because in my system, which has got the inverter, which has got a battery backup, I've got a sub system or a sub breaker box which comes off that. And those are which I run my critical loads. So when I say critical loads, what I'm trying to cater for in a system like this is that if the grid goes down, I've got residual power that I can draw out of the batteries and then run the critical loads. What I'll end up in, and I'm still in the process of doing, is having things like the lighting, the fridge, perhaps basic entertainment systems, because they don't draw too much current, off this sub breaker panel. Things like the range, the air conditioning system, a tumble dryer, for instance, which draw a lot of current. I don't want that, and I cannot sustain them running off the system that I've got, and I don't really need them in a power outage. So they're going to still run off the main service entry breaker box. In this system, even though it's a grid tied system, there are a fair few options which are becoming very interesting, because the natural inclination is, if you're going to run a grid tied system, is to be able to, from your solar array, the power that you're generating is to use what you need to inside your home and then push the rest out onto the grid so that you can earn money from doing that. and it's called a net metering system. So in theory, you don't have your own battery bank. You use what you need, and when you've got excess, it's pushed out. You gain credit for that, and let's say during the night or in winter when you're not generating as much, you're going to draw more from the grid. And depending on how much solar power or renewable energy source, you're going to try and balance out your costs between what you use, push out, gain credit for, and then draw back from the grid. But there are some interesting situations which mean it's not almost viable to push power out onto the grid. In South Africa and other places around the world, and even in the States, sometimes it's not easy through your local electrical authority to get the permission to push electricity out on the grid. Sometimes there's a lot of paperwork, they require a certain standard of equipment, and the benefits that they give you in terms of payment may not be beneficial. Also, there are new laws being instituted, particularly in the States, when our electrical companies around the States are saying, well, people seem to be profiteering from pushing back power onto the grid and earning money from doing that. And they're saying now there's a law that they're contemplating around the States is that they will not allow you to generate more than 110% of your requirement. So there'll be an average household usage. You're not allowed to generate more than 110% because they don't want too many people pushing too much power back onto the grid. And I'm sure that's going to spark some interesting debate. But that's where the system that I've got caters for those situations. What it does, the various modes of the inverter that I have allow you to either feed back onto the grid if that's what you want to do and your local authority allows that, or allow you to intelligently use the grid when you need it, but mainly concentrate and use your renewable resources yourself, so that you can set the system up so that you generate your own power, you use it for your own household requirements, any excess gets stored in a battery bank. Now, of course, there's an extra expense and losses associated with that. But if you cannot push it out onto the grid, rather than wasting the energy, you want a storage system. And that's where hopefully there are going to be developments in the near future which bring the price down and the losses in terms of the energy loss going into these storage systems. But these modes on the Outback in particular allow you to do that. Either switch off the grid and then bring it back when you really need it to either recharge your batteries or if heavy loads switch on, or they've got something called Grid Zero, where the system will basically allow you to use your renewable resources and keep a little pipe open onto the grid, which has got a little trickle feed onto your system, and it opens that up as, let's say, your batteries run down to a certain level which you can set, or if you switch on appliances which suddenly need a high power draw and you don't want that power draw to necessarily come from your battery system or your backup system, it can draw the excess power from the grid and blend in a reasonable amount of power from your renewable energy resources. So they really have got clever in that system. Now, the one thing I want to point out before we go into any further detail on this system, because we're going to have an in-depth discussion on this inverter and what it can and can't do. But one of the issues that still exists is that this inverter can accept power from the grid. It can take it from your renewable energy, in this case solar panels. And obviously in this case, I'm using the Enphase inverter, so I'm getting AC power from my solar panels that comes into this inverter. Now inside this inverter is something called an H-bridge, and the H-bridge is something we'll go into more detail with, but basically it will rectify the AC power to allow DC charging of the battery, or it converts the DC into AC for use on your loads. Now the problem and challenge with this bridge is that only one side allows proper charge control and regulation of the current that flows into your battery bank to charge your batteries. So if you are charging your batteries or receiving power from your main service grid or the main grid input, that flows through, it goes through a proper charge controller to make sure that your batteries aren't overcharged. However, if you are receiving that power from your solar panels and coming through the other side of the H-bridge, there's no regulation and your batteries can end up being overcharged. Now, this has been a problem across inverters to date. It is a problem that I never fully understand why it should exist, but now understanding the H-bridge setup and where they put the charge or regulation of the current, I can see where the issue exists, but I still can't understand why they don't choose a simpler way to get over the problem. What inverter manufacturers have done in the past, and my system in South Africa from Victron Energy was one of these, what they do is that the inverter will monitor the voltage of the battery bank. Because the power that's coming from the solar panels is not being controlled by its charge control system, it will then change or do a frequency shift of the AC frequency which the grid-tied system is looking at, and it'll change that frequency, and then the grid-tied system, which is associated with the solar panels, will start to throttle or pull back on the power production from the solar panels so that you don't overcharge your battery system. That system inherently has a few issues, as I noted. For one, if you have clocks which are tied to your AC frequency, let's say 60 Hertz or 50 Hertz, things like clocks on microwave ovens or even bedside clocks sometimes use that frequency to keep time. And you can often find that your clocks run faster or slower, and more often than not faster. I've also noted that sometimes it can affect the lighting in the house, particularly if you've got LED lighting which reacts very quickly to any changes in frequency. The lights can end up flickering. So although it's an attempt, it's a bit of a fudge and often doesn't work very well. Now Outback have employed another system which I'm going to demonstrate in the video after this, is where they have a remotely operated circuit breaker. So your power comes in here, the inverter will monitor the voltage levels on your battery bank, and when it reaches a level where it's potentially going to be overcharged, it will remotely switch off the circuit breaker, which has got the AC power coming in from your solar panels. So that's one way of doing it. It's certainly better than nothing, but I think there certainly could be improvements in the system, and that's what we'll talk about again once we go into detail about the inverter. Let me just physically show you my installation, and then we're going to go outside and have a look at the installation of the microinverters on my solar array. So this is the physical layout of my system. I've got the main service entry of the electrical system from the grid, which comes in through this breaker box over here. I then have a feed, and there are two feeds which I've got. One carries the two lives and the neutral, and the other carries the earth cable. And this is something we're going to talk about. There's a few things which can catch you off guard depending on the way you carry your conductors through to your other breaker boxes. That then comes into what is called, Outback call their kind of AC coupling load center. Now this box, and we are going to open these up in future videos so that you can see the wiring. This box aids in the wiring, bringing all the wiring systems together to allow ease of connection to your main service, to then your loads that you want to take, your critical loads in your other breaker box, and then up to the inverter, and then down to the battery system. The battery system I still have below. I've still got tools because I'm still working on the system, because I'm tying in the rest of the circuits from the house. We then have this something called the Outback Mate system, which is a configuration device which allows you to configure various Outback products. In this case, it can configure the inverter, it can configure like the FlexMax charge controllers or your battery shunts. We then have the Envoy system, which is connected to the internet, and that controls and communicates with the Enphase microinverters. The inside of the kind of AC load center or coupling center has got a few breakers. And then this over here is the remotely operated breaker circuit, which can disconnect my Enphase systems and my solar array. It's also got some big DC breakers from the battery bank. This is my new critical load center, where I've got at the moment only two breaker switches, only one's connected. I've got an outlet which is running some loads while I test the configuration of the system. But that is something we'll open up and take a closer look at as well. You need to be very aware, although I've done the system myself, it can be very dangerous working with electricity, and that's why I plan to cover off the AC system and all the ins and outs and things you need to be aware of. And if anything, by discussing that, I don't hope to try and help you do the system yourself. I'd rather show you the risks that are associated, so that if you've got any doubt, rather call on a professional, because it can be very dangerous, and you certainly need to ensure that you work to the codes, the electrical codes of your system, and don't do anything that's going to perhaps harm your household, which is very easy to do, and that's something I'll highlight in a future video. Okay, I'm now at the phase where I've got the ground mount system all set up. I had the panels on initially just to make sure I got the levels right with the support rails. I've now gone and had to obviously remove the solar panels so that I can now mount the wiring and Enphase microinverters. So these are now being mounted just off center of where the solar panel sits, because there is obviously a mounting strut which is up here, so that makes things tight. These have to be mounted with the aluminium kind of heatsink area facing up, not the black back end. So these get mounted, and then what you need to do is ensure that you get the cabling system which is supplied with it mounted onto the rail, in such a way that you don't. There are a couple of holes here which look like mounting holes, but they're not. They are for the plug. The plug has got 2 points which actually plug in. This is a cap, a shipping cap, which has to come off. And those holes apparently are used as part of a release system to release the plug. So you need to secure it either side. You can get very handy little clips which clip onto the rail which hold the cable. I didn't get that with the installation, and as this is temporary, I am just using zip ties, which are okay. I've seen in the instructions you can use zip ties. This cabling then needs to go right along, matched with the rest of the units. And again, obviously making sure that the plug which comes off the microinverter is within reach. It's not obstructing the solar panel when it goes on. The mounting of the microinverters I'm doing with what I had to do because I didn't get screws or bolts, nuts and bolts to mount them onto the rail. I'm using these bolts which are used to hold the actual panels on. I had a few extra and I've just cut them off to size. They can't be too long because they're underneath the panel and they'd obviously hit the panel. So they're short enough, they're nice and easy to slot into the rail. They need to be twisted, and then that's how the microinverter is mounted. It's got a built-in grounding system within these microinverters, which is handy. One very important thing to note, there's a serial number for each of the microinverters stuck onto this aluminium plate, and that is replicated on the bottom. Now the reason I'm saying is that the one on the bottom you leave in place, but the one on top you remove and place on a map. You set up an array map so that each of your solar panels is mapped out for the data which is uploaded onto the website. So you've got your kind of envoy gateway, and that information, then you can track the performance of each of the microinverters and hence obviously the solar panels. So that's what you remove, you place on your map of your array so that you can configure that on the gateway system. At the end or terminated end of the array, so basically I'm running the wiring from this end, it's going across the array to that side. That's where I'm going to have a shut-off switch. You need a safety shut-off switch to shut off the AC from the outside. So I'll have a waterproof AC terminating box at that end with a switch in it. But at this end, we obviously end up with a piece of wire which has got the conductors exposed. Now those are going to be live with 240 volts of electricity. And there is a special end cap which is supplied where you strip this wire, you pull the individual wires out, so they're separated from each other, and then they are encapsulated in a waterproof cap. And that forms the end point, which is then safe and waterproof. And I'll demonstrate that once I've got it fitted. One important thing to note is those nice nuts and bolts, they are set up. If you get the right ones, they'll twist in, but then they lock in when you're tightening them up. You also need to be aware of the metals. You can get a galvanic reaction between the different metal types, especially with aluminium. So you need to ensure you use the correct metal type so that you don't get a reaction and then corrosion taking place. Okay, so I've spent the full day virtually out here now, kind of putting the panels off, putting the microinverters on the back. Everything's back together. Everything's almost wired up in terms of the microinverters being on the back and the wiring being strapped up ready. I've also inserted a disconnect, which is required outside, so that if any authorities or what have you need to, they can disconnect the AC circuit from outside as well. The Alti store actually provided all these warning stickers with all the equipment, which is really handy. You'll note, so everything is connected up. The microinverters are screwed on. Now when I say connected up, they're screwed on, but none of the wires are connected in. You can see they're all hanging in. So the DC wires from the solar panel and the microinverter which plugs into the wiring, which is obviously along the framework, that's all disconnected. You do not want to connect that up until you're ready, and there's a specific order that you connect it up so that you don't work with anything live at all. So everything remains disconnected, and I'll show you and I'll explain the ordering of the way it's connected up once we actually bring it into service. So I'll just show you. I've got the end of the wiring which comes into the disconnect. Just a note, I do have an extra AC wire point for an extra microinverter and panel, and on there they have provided a specific blank which plugs in there to seal it if it's not being used. If you note on the other ones, they've got those red covers. That's for shipping until you actually connect it up. Those pull off easily once you actually plug the plug in, but they keep them sealed off. But this specific one is there for weatherproofing. So if you're not connecting anything up, you need to put a proper weatherproof cover on that. We've got the photovoltaic AC disconnect labeled. I've gone and loosened the screw just to show you the wiring inside. We've got the two live legs, live 1, live 2, coming from that wiring loom, which obviously connects up to the microinverters. We've got a neutral. On the neutral, I've got one of these wonderful, is it Waco connectors. We're going to talk about those, but that I'll connect into there when we have the wiring that goes into the house and into the distribution board or breaker box. And then the earth is going to an earth bus. So this, I'll have a second wiring which goes in here, protected in a conduit which leads off to the house. But for the time being, everything's now ready. I'll just show you what the stub at the end of the circuit looks like. So at the other end of the AC wiring loom that connects all the microinverters, you've got a piece of wire that ends, and you'd have conductors which are potentially exposed. So they provide you with a very specific stub connector which seals it all off and makes it safe. On the diagram, I'll just show you what it looks like. There's 3 pieces to it. They show you how you push the wiring through, you pull the individual wires through, cut them off, and then they get bent over and sealed in there. So I've gone and done that. I'll just show you. There are the wires. They spread out in those little crevices. And now what I have to do is push this cap over that. There's a rubber seal, so they're sealed, they're separated, and that makes it safe. So I'll just show you what that looks like once I've got the cap on. So there we go, this cap is on, and what I hadn't realized and what they cleverly do, you can see these little arms ratchet onto here. So this is a one-time use. You have to put a screwdriver in there to add leverage so you can tighten this up. It clicks, obviously these meet here, they click up, ratchet in, and that's locked on. You're not supposed to take it off. It's designed to be there permanently to keep it safe, so it can't be fiddled with and someone can get a shock from the connectors at the end. It is nicely sealed and held tight in this end as well, so a nice way to terminate the end of the wire, and certainly something to remember to do once you're at the end of the AC loom. What I am going to do is connect up all the connectors, because I don't want any weather or muck or dirt or moisture to get into any of the plugs and connectors at this point in time. As I've got the AC disconnect connected now, and it's obviously switched off, that means it'll keep all the microinverters dead. They won't see any AC, even once I've obviously connected up to the household AC. So there's no risk of things going live. So I'm going to connect these all up. It's the end of the day, and then I'll connect all the solar panels. What I want to demonstrate, and I know the lighting is very difficult to show you, there's a nice rubber seal going right around that connection point. You'll note there's an arrow over there which denotes which way the actual connector goes. There's another arrow which is there to match up, and that's where these come in. And then there's a nice solid flit and click. Those 2 little end pieces click and lock in, so that you've got a nice connection, secure and weatherproof connection with the AC connection going into the AC loom.